Well, welcome to this video. This video is going to look at two things. It's going to look at the final bit of a river, which we call a river basin, and then it's going to look at what the hydrological cycle is. And so by the end of this, you should know what a river basin is, you should know what we mean by hydrological cycle, you know the key processes, and you should know what the flows and the stores are. So there's lots to be getting on with. Now, before we do that, let's just take a step back and go back to the previous work. So a little sort of starter for you. There's 9 things here. What I want you to do is stop the video, okay, and decide whether they are typical of the upper course, so sort of near the source, if you like, of the river, so this sort of section up here, or whether they're typical in the lower course, sort of section near the mouth where the river meets the sea. So just stop the video for a second, okay, write them out. You can just write numbers down if that's quicker, okay, and so decide, waterfalls are the upper course or lower course. So stop the video, have a go, and in a second we'll go through them. Okay, well, I hope that was fairly straightforward. So we'll keep going over this stuff again and again. It's really important that we master this stuff before we move on too far. So hopefully you have got this, but we will keep coming back to it. So let's have a look. Okay, so number one, waterfalls. That's going to be typical of the upper course. So high energy environment, requires sort of hard and soft rock and lots of vertical erosion. So it's very much upper course. And using that logic, our vertical erosion, okay, is going to happen where the river's got the most energy, and that happens where it's steepest. So that's going to be the upper course as well. Now, the river is wide and deep, and you can see here, even on this little sketch, as the river goes down, more rivers will be joining it, more rain will be joining it, so the river is going to get wider and deeper. So that's going to be a feature of the lower course. Whereas the river's shallow and narrow, well, again, that's going to be because there's less water in the river, so that's going to be upper course. A steep gradient, again, if you have a look here, nice and easy, that's the upper course, we can see that. Large meanders and oxbows, and as we go down, what we'll see is the river always meanders, but the meanders tend to become larger as the river becomes larger. So again, large meanders will be typical of the lower course. Whereas a narrow V-shaped valley, well, that's going to be caused by vertical erosions. We expect that in the upper course. A large floodplain, okay, might be tens of kilometres across, is going to be typical of the lower course, where you've got that sort of lateral erosion from side to side. And a shallow gradient, again, we can see here that the shallowest gradient, can be less than 0.1 of a degree, in fact, is in the lower course. So that's just a very quick recap of what we've been doing for the last few lessons. And just want to do that before we go on. So, like I said, the aim here is to look at a river basin and look at the hydrological cycle. And it's worth thinking about how this fits in. So we've started this unit by looking at river processes, and then we looked at the upper, middle, and lower course. And last lesson we were looking at how they change as you go from upper course to lower course, what we were just doing a second ago. And what we're going to do is going to finish off looking at the different features of a river, which we call basically the river basin, and then we're going to move on to the water cycle. Okay, and going to look at what happens to water in a river basin in the environment. Okay, so this is what a drainage basin is. Basically, a drainage basin is the area of land drained by the river and its tributaries. It's where the river gets its water from. So any rain that falls inside this area, if it's going to end up in a river, will end up in this river. Okay, and there's a number of key terms. And what I'm going to do is I'm going to talk through the key terms, and then second go to another slide, which has got this and the key terms. You should have it on your worksheet, and your job is going to be to fill in the definitions or get the correct term against the right definition. Let's go through it. So when we start with a river, what we actually do is we start at the source. So that's going to be a spring normally, it might be a glacier where it's melting, but normally in this country it would be a spring, and that's where the river starts. And you can see as we go down, there are other rivers joining it. Well, a small river that joins a bigger river is called a tributary. And you can see there's tributaries here, there's tributaries here, in fact, lots of them. You've then got a point where two tributaries meet. So it could be here, it could be here, here, here. Anywhere where two rivers meet is called a confluence. Okay, so if you confer, you talk to someone. If you have a confluence, it's where two rivers are joining. So it kind of means joining, conferring. All of these words, con, basically means sort of two things joining together. A confluence is where two fluid things two rivers are joining together. You've also got the sort of main river channel. That's the bit where there's normally water in. So that's kind of the key language. Now, by far the hardest one to get your head around is this idea of a watershed. Now, a watershed is basically the boundary of a river. And nearly always what happens is there's hills. Now, water flows downhill. So this sort of range of hills here marks the boundary of the river basin. So if there's any rain, and let's draw my rain cloud here, it says, try and make sure it's blue. So here's my rain cloud. If there's any rain that falls this side of the hill, it's going to flow into this river. But if there's any rain this side of the hill, that hill is in the way, so this will flow into a different river over here. It's in a different drainage basin, or sometimes called a drainage basin, sometimes called a river basin. It means exactly the same thing. So that is the watershed. And like I said, of all the things on this diagram, it's the hardest one to remember. But it's simply, like I say, the boundary between two river basins. So that's me going through them. Your job is now to have a go, stop the video, have a go at filling in those definitions. Okay, remember the key words are over here. Okay, so have a go, see if you can work out what the definitions are, and I'll go through them with you in a second. So stop the video and we'll do that in a second. Okay, so let's go through them. Well, number one, the starting point of a river. Remember, that's what we call the source. A small river that flows into a larger river, that's what we call a tributary. The line, remember, this is the hardest one to remember, the line around a drainage basin, okay, is the watershed. What the actual river flows in is we call the channel. Where two rivers meet, remember we talked about that confluence, and where the river enters the sea is the mouth. Okay, so make sure you've got that actually labelled, and that's the key language of a drainage basin done. Okay, so next question is, where is the world's water? So an amazing 97% of all the world's water is actually in the sea, salt water. So there's only actually 3% of water that we can actually drink. And what I want you to do is have a look down here, and you'll see down here in this section here, I've put the answers. All I want you to do is on your sheet, jot them down in order of what you think is the most common. Where's the most water? Starting with number 1 at the most and going down to number 5. So stop the video, have a go at that, and we'll have a look through the answers in a second. Okay, well, these are the answers. I'm not sure if I necessarily would have got these, to be honest, if I was you. But number 1 is ice. Well, that makes kind of sense because of the sort of Antarctica and Greenland, these massive ice sheets. But I'm not sure I would have got 2, 3, and 4 in the right order. I always would have thought far more in the atmosphere. You can get all those clouds and things, but actually comes in at number 4. Number 2 is groundwater. Rivers and lakes comes in at 3, and last is biomass, of living things. That's water that's in trees, inside you and me, and things like that. Now, what that actually means is that if you look at this, ice isn't going to go anywhere very fast. It's kind of, it's going to sit in Antarctica for hundreds, thousands of years. But actually, these next 3 are all interconnected. And to a certain extent, to be honest, so's the biomass. And that's what we're going to look at now, this idea of how these different sort of parts of the world, the ground, the rivers, the atmosphere, the living things are all interconnected. And that interconnects what we call the hydrosphere. Now, this is all the Earth's water. That includes the surface water, the groundwater, the snow and the ice, and any water in the atmosphere. Now, as we said, that sort of a hydrosphere, the water on the Earth, basically keeps moving around, and that journey is what we call the water cycle or the hydrological cycle, and that's what's shown here. And basically, it's just a repeating process. It starts with evaporation. Okay, so the water is evaporated from the sea, goes into the air where it condensates. That then forms clouds. Those clouds then form rain or snow, what we call precipitation. The water falls back to the land, flows to the sea, and the whole thing starts again. So that's what we call the water cycle, and that's what we're going to look at now for the rest of this lesson. So this is an example of the sort of water cycle going and working inside a river basin. And what you'll see here is that it's coloured in two things. So on one hand, you have got things like evaporation, you've got transpiration, precipitation, evaporation. Now you notice a lot of these end in ation, and that's because ation as a suffix, so end of a word, means a process. And so these are all processes, these are all moving water around, what we call flows. Now, yes, the water's moving around a lot, but sometimes it will stay put. So for example, it might just hang around as a cloud in the atmosphere. It might hang around as a puddle on the ground or in a lake. It might actually just stay in the soil or in the rocks, or it might be in a lake. And if it's stationary, we call that a store. So you've got these two key ideas, okay, of when we're looking at a hydrological cycle or any cycle, which are stores and flows. So what I want you to do is in your notes, can you explain what those two things are and give some examples of them? So just stop the video, get that done, and then we'll go and look at some of these processes in a bit more detail. Okay, so again, I'm afraid there's lots of key terms here, loads and loads. In fact, you've got all of these that you need to know. So what I want to do is stop the video and have a go and see if you can work out which one of these matches these definitions. Okay, so stop the video and let's see how you get on. Okay, so let's go through these one at a time. Unfortunately, these boxes here are a bit small, so I'm going to read them out here and we'll pick out the right answers here. So let's start with condensation. So condensation is when water vapor turns back into water. Okay, it's basically what forms clouds. So let's have a look through here. Okay, and let's have a look. So we want this one here, the process by which vapor in the atmosphere becomes water, i.e. turns into clouds. Okay, let's go on to the next one then. So transpiration. Now, if something transpires, it's basically when a plant is breathing out, for want of a better word, okay, during photosynthesis, it actually, plants emit water, and we call that transpiration. So that is moisture lost to the atmosphere through the leaves of plants. Okay, let's go on to the next one. So precipitation. Now, as geographers, we often talk about precipitation. We don't call it rain. And that's because precipitation can be rain, snow, sleet, hail, any form of water that falls to earth. So we've got precipitation up here. Okay, so far so good. Now, the next one is through flow. Now, geographers are an unimaginative bunch. So through flow is the flow of water through the soil. So what you're looking for here is here. Okay, it's where water passes through the soil. Okay, and like I say, we are an unimaginative bunch, so actually some of these are a bit easier than others. Okay, then we're on to groundwater store. Well, it's a store, so it's somewhere where the water is stored and it's in the ground. So what we're looking for here is something where water is stored in the ground. Okay, in the rock basically. And if we have a look here, we've got water held in pore space in the rock. Okay, moving on. Back to yellow, we've got interception. Now, if you think of interception, I don't know, police car intercepting a bank robber or something like that, it means sort of catching. An interception happens when vegetation catches rain. So think about a wet, miserable day. You've been out playing football, so suddenly the clouds have burst and there's a huge storm. You go and hide underneath trees, and you hide underneath trees because the leaves catch the rain. Okay, they actually intercept the rain. So we call that interception, and it's when the vegetation intercepts the rain. It stops the rain falling directly on the surface. Right, then we get on to percolation. And oh, let's just change the color for that one. Makes it a bit clearer. Let's try, oh dear, that's not much better. We'll try bluish. That's that color blue we're after. Now, percolation, I always think of a coffee percolator here. That's like a thing where you've got coffee sort of granules and grounds in and water soaks through it. And percolation is when water comes from the soil and soaks into the rock underneath. So what we're looking for, okay, is water moving from the soil, okay, into the rock. And I'm guessing, okay, that's the closest one we've got to it. Water moving slowly downwards from the surface. Really, it should be the soil into the rock. Okay, moving on. We've then got evaporation. Okay, and again, that's meant to come out green. And evaporation is when water turns into water vapor. So it's a bit, it's not exactly the same as boiling. Okay, this is something a bit more gradual than that. So you're not going to see bubbles and things, but literally the water is just turning from a liquid into a gas slowly. Right, then we're on to surface storage. And again, storage basically means it's a place where water's hanging around and it's on the surface. So what we're talking about here are things like puddles, ponds, lakes. So again, it's going to be that one. Infiltration is a bit like percolation, but this time it's the water going into the soil. So it's in a puddle and it's slowly seeping into the soil. So let's have a look, see what we've got here. Here we are. Water gradually seeps into the soil. Now, evapotranspiration is basically a mixture of evaporation and transpiration. So it is anything that is bringing the water back into the atmosphere. And so it's a combined evaporation and transpiration. We're nearly there. Groundwater flows is going to be any flow in the ground, so in the rocks. So it's where water is moving through rocks. So I'm guessing it's this one here. So those rocks will be pores and cracks and things. Overland flow. Again, remember, as I said, geographers are a pretty unimaginative lot. Overland flow is when water is flowing across the surface. We sometimes call that surface runoff because it's running over or off the surface. And lastly, I guess we should also know soil, and even I can work out it's that one. So what I want you to do is I want you to make sure, please, that you've got that filled in correctly. And these are key terms you're going to need to know. So can you make sure you've learned them? So they're the key terms. Now what we've got to do is think about what it looks like in sort of actually where it's happening. And this is where this diagram is really useful. So what you're going to do is we're going to work through this diagram, okay, and go through the task. So if you look at the first task, the first thing we're going to do is we're going to label the boxes. And all of those boxes are going to use the words that we've just gone through. Then we've got 5 key words here. If we look at number 2, okay, that you need to define. Again, I'll give you the definitions, you can match them up. Number 3, complete the key below. What are stores, what inputs, outputs, and flows? Now we've done stores and flows. Inputs is anything coming into a system. So if you've got, for example, a water, I don't know, a cloud, for example, raining into a river basin, that's your input. And if you've got the river flowing into the sea, that would be your output. Now, if we're talking about a river basin, you can have inputs and outputs. If you're talking about the whole world, well, there aren't inputs and outputs. And that's the difference between what's called an open system, i.e. you've got inputs and outputs, and a closed system, where you're looking at absolutely everything. The water can't go anywhere, can't leave the system, so it's a closed system. And on this one, you've pretty much only got inputs and outputs. And then the final thing we'll do is we'll have a little look at the extension question here. How will stores and flows vary in summer and winter? So let's go through this one step at a time. So your first job is to add the labels to the correct place. So use that list of words we just went through, go through and colour those in. And then when you've done that, you've got those 5 key words, okay, underneath the diagram. Here are your 5 answers. What I want you to do is match the correct answer up with the key term, and then have a go at the stores and flows and color code as we are. So stop the video now. I'll talk through each stage in a second, but I want you to have a go at it first. When you think you've got done or you've got stuck, then press play. Okay, so here what I've got done is the diagram. You can see what I've done is I've got it labeled. I've also gone through and I've color coded in the flows and the stores. So the flows are in yellow, the stores are in a sort of pinky color, I suppose. So check you've got it right. When you're happy with that, okay, we'll move on. A couple of key things we haven't really spoken about. We haven't talked about the water table. And the water table is this boundary here. And basically, think of a well. If you were to put a well, let's draw a well in here. Here's my well. Where's the water in a well? And the answer is the water in a well is in the bottom. So here's my water. And if it rains more, then the well will fill up. And if it gets dry, the well will go down. But the actual point, the top of the well, where the water is, sorry, is actually the water table. And it's the division, the line separating saturated rock, okay, and rock which is unsaturated. And basically what happens is that when it rains, water will seep down through the unsaturated rock and will start filling in this bit down here. And if there's more water, then, like I say, the water table will rise and my well will fill up, okay, and if there's less, it will go down. So that's just a little bit on this diagram which we haven't talked about already. Okay, so you've got that diagram done, hopefully. So let's have a look at the other questions. So then number 2 was asking you to define the key terms. I've got my definitions here. So saturated rock, which is rock full of water. Unsaturated rock is dry rock. Well, basically rock that isn't full of water. Can actually have some moisture in it, just that it's got space, it's got air in it. The water table is the line separating saturated and unsaturated. 2 other terms. Now, permeable means that the water can travel through it, and impermeable means water can't travel through it. A granite or mudstone or something like that won't let water through. And number 3 you should already have done. So again, stop the video, make sure you've got those written down, and we'll just quickly talk about that extension task number 4 before we move on. Okay, so the challenge question was, how will stores and flows vary in summer and winter? And just think about this. So in winter, what's going to happen? There's going to be more precipitation. If there's more precipitation, that means that there's going to be more water going onto the soil. So the soil's more likely waterlogged. And if the soil's got loads of water, there's more water likely to percolate into the rock. So the groundwater is likely to be greater. So the water table will rise. You might well find that if the ground and the soil's saturated, well, then there's probably going to be more water traveling over land, and that will increase the risk of a flood. You've probably got in winter less vegetation. You think trees lose their leaves, there's less transpiration as well. There'll be less interception, so water will get to the ground quicker. In summer, the opposite's true. There'll probably be less rain. There'll be warmer, so there'll be more evaporation, there'll be more plants, there'll be more of that transpiration. The chances are that because it's drier, if there is any rain, it's less likely to stay on the surface. It's going to soak straight, it's going to infiltrate into the soil and percolate in. Because there's less water, probably rivers will be less. Okay, and because the soil won't be saturated, there's probably less chance of a flood. So that's the kind of differences between summer and winter. Now, 3 key things which we need to think about this for next time is, how does water get into rivers? Okay, and you've got 3 options here. Okay, you've got groundwater flow, you've got through flow, okay, and you've got overland flow, surface runoff. And just what I want you to do is stop and have a think about which is the quickest and which is the slowest. Okay, well, the answer as to what's quickest is overland flow. Okay, if you had to get from A to B, you just walk there. You wouldn't dig into the ground and try and tunnel through. So by far the quickest is surface runoff or overland flow. The next quickest is going through the soil. That might take hours, maybe in a day or two. And the longest, and just simply because of the route it's going to take, is through groundwater flow. So the rule of thumb is that the nearer the surface, the faster it is, with surface runoff being massively, massively faster. Whereas groundwater flow might take months or even years. And it's the reason why a river like the Thames still has water in it, even during a drought been going on for months. So that's really important, but we'll come back to that next lesson. Okay, so finally, just some quite challenging questions actually. Let's go through these and see if you can work them out. So number one, I'll go through the question, I'll pause, and then I'll go through the answer, see if you've got it right. So if precipitation and leaf drip are greater than infiltration, and leaf drip is the water coming off the leaves, are greater than infiltration. Now, infiltration is water soaking into the soil. What's going to happen to surface storage and what will happen next? So just stop for a second and just think. Surface storage is puddles. Basically, you can get more or less puddles, and what might happen if you've got loads of water on the surface. So stop for a second and I'll go through the answer. Okay, well the answer to this one is basically if more water's ending up on the surface and can soak into the soil, then you're going to get more and more puddles. And if you've got loads of water on the surface, it's going to start flowing over land into the river, so overland flow, surface runoff, and it might well cause a flood. So that's the first one. Okay, let's have a look for number two. So number two is if infiltration is less than percolation, will there be any through flow? So again, just have a think. So percolation is the water going from the soil into the ground, and through flow is the water traveling through the soil. So what do you reckon? And the answer is not very much. There may still be some, but it'll be minimal. Okay, because pretty much there'll be very little in the way of water stored in the soil, so there's very little to flow through the soil, so the vast majority will end up in the ground. Okay, number three, what will cause through flow to occur? Why would you get water going through the soil? So again, have a think, stop the video and I'll answer it in 2 seconds. Well, the answer to this is if basically the rock underneath the soil is saturated, or if the percolation is very slow, or if the rock is impermeable. Either way, if you get a build-up of water in the soil, it will start to flow through. Okay, number four. What happens to the level of the water table if percolation is greater than groundwater flow? So basically, this is the water is going into the rock quicker than it can flow through. So again, think of the well. If the water is flowing into the rock underneath very quickly, what will happen to the level of that well? And I hope you realise that if there's water is disappearing from the soil and is going into in the ground deep underneath, then actually the water table will start to fall. Okay, number five, what causes interception? Again, think, where do you hide when you're caught in a thunderstorm playing football or something? Of course, the answer is under trees, vegetation. And lastly, after a period without rainfall, what store would be the last to dry up? Okay, and if you think about this, well, anything on the ground, on the surface, like puddles and things, that will evaporate really quickly. Next, the soil will dry up. Okay, and then finally, the water in the ground and in the rocks deep underneath, which are protected from evaporation, will start to dry up, as will the rivers that sort of feeds. So I think it's quite tricky questions there, but if you've got them, you can feel quite chuffed about yourself because you actually really understand it. And that's it for now. Please remember that you can email me any questions. There'll be a quiz later on in the week, which I'll put on ePraise and email you. You also need to be thinking that you've got a test coming up in about 2 weeks. We'll give more details of that when we know exactly when that is. I'll also try and be on email and Teams 2 till 3 o'clock every day, so you can contact me there. Right, thanks so much. I hope that's been helpful, and we'll talk no doubt next week too.